Yeah, my name is David Trayte. I'm with the National Park Service. Very happy to be with you guys today. I'm coming to you from Washington, D.C. at our office here. Let's start with storefronts. So I'm also going to turn this camera off only because I have some freeze up here with my government systems. All right, so we're ready to roll. I'll start with storefronts. The question is, why are storefronts even important? Why do we even look at these? Why do we care? The storefront is typically the most prominent feature of a commercial building. The original purpose was to advertise for business and allow pedestrians a view of merchandise into the store. The original storefronts in any project should be identified, retained, and preserved. And we'll look at some examples of that, unless either they're deteriorated beyond reasonable repair, as Kim has discussed, or they're even missing totally. There we go. All right, so by the early 19th century, commercial buildings often had very regularly spaced piers of brick or stone. They were often infilled with panel doors or larger pane window sash, as you see in the upper left image. This is a residential commercial combined building. That's what we typically saw. During the mid 19th century, there were advancements in the glass industry that led to larger pane sizes, which allowed for larger, what we know now as more true display windows. Simultaneous advances in architectural cast iron allowed for the combination of this large glass with very thin structural elements. And this led to even larger views into these spaces. So let's talk about the anatomy of a storefront. This is really the key component here. What is this? How do we break these pieces up? What are we interested in? So if we start at the very base of this and work our way up, we have the wood or metal bulkhead, sometimes referred to as a knee wall. And then we also have a recessed entry in this case. Above the bulkhead, you have the display glass or the display window. And then transoms typically are above that. Not every storefront has a transom, but we often see them. Some might have a signboard above that, and then other architectural details as you move up to the second floor. So this three-part component is important in just the basic compatibility and detail of a storefront of traditional 19th century era, especially. The building's structural support was not uncommonly supported behind the storefront rather than always incorporated into the storefront frame itself. And this allowed for much thinner, more delicate framing profiles. You can see some historic drawings of that configuration there. Very thin framing profiles and metal construction became widely used for storefronts much earlier than people realize, even as we start to dig back through all this. Also notice the base and the bulkhead is not a panel, but stone veneer in this image. Decorative vents are shown on the one on the left. Tile became popular for bulkheads, and also don't forget that prism glass became very popular within the transoms, as you see in the upper right. Storefronts have a wide range of distinctive materials as we continue through time. In the 1920s and all the way through the 50s, pigmented structural glass with trade names such as Carrara or Vitrolite, you guys might recognize those, became very popular. While these might not be the original storefronts per se, a structural glass storefront often has achieved significance over time and should be retained. Preservation Brief 12, available on our website, deals with that, specifically with structural glass. In these images here on the screen, there's a recessed storefront that's also stepped with very small metal connections at the glass panes, which essentially created a frameless system, as well as some nice tile detail. So acquired significance is something to keep in mind. By the mid-century, storefronts were characterized by bright, bold colors and signage. We had aluminum finishes, clear aluminum designs that incorporated the entire facade of a building. These are things to consider when you're looking at perhaps a district's period of significance. Were there modernization efforts that were across the board that alter these buildings significantly, and are they important? If we look at treatments of storefronts specifically, we can break this down into three categories. The first is to retain what you have, what's there that's existing. And here's an example of that. That's before on the left, and a nice after shot of the completed rehabilitation on the right of the historic storefront system retained. Let's say you have something that's not original, but it is historic. although this storefront, again, was likely altered over time after its initial construction, it was a significant change. And again, look at acquired significance, look at the quality of the materials and its design. Does that make it worthy of preservation? In this case, probably so. The second treatment of the three is to restore a historic, well-documented design if you have that information available. This is an example of a texture project in North Carolina that included the restoration of 2 street facades following the removal of a 1970s brick and stucco veneer, and some of the historic features actually remained intact beneath. We also had this really good photo, well, I guess the best photo we will ever find, that gave us some really good detail of what the historic configuration was on this building. And so we were informed by this in our decision-making process to then determine what to put back. And in this case, the applicant went above and beyond of truly a restoration to some extent. They included putting back prism glass transoms, the large storefront openings, and you can see the before and after shot there. There's a striking difference between those two in terms of not only rehabilitation, but most likely even elevated to a restoration level of work. And the third treatment is design a compatible new feature. So let's say that you're designing a new feature where, well, I should say the majority of our projects fall within this, where we have nothing left. And the buildings here are fairly typical of commercial buildings that we see in our program and have fallen on hard times. We've all seen these type of buildings, and they are certainly in some desperate need of some love. There's very little, if anything, left on the first floor in terms of historic features. So the only option really is to design a new storefront that the keyword here is compatible. So what does that mean? What does a compatible new storefront entail? And so the factors that we look for are these ones here. And so the top example is a typical late 19th century commercial building. The new storefront is very traditional. It's constructed of wood. It's a little bulkier perhaps than what we historically would have seen in some places, but there are a lot of divisions given a somewhat vertical emphasis to the design, which is okay for a building of this style and period. A notable aspect of this design is that the division of the display windows is not matched exactly to that in the transom. And as designers and architects, we struggle with the desire to always want to line up regulating lines and have everything very clean and neat and organized. That's not always the case in storefronts. In fact, if we were to follow the transom divisions, we'd end up with much smaller display windows, which would not be appropriate. So don't be afraid of offsetting those to achieve each of those three components as they should be. Again, the bulkhead, the display, large display windows, large as they can be, and then the transoms. The second example at the bottom is a 1920s-ish building. The storefront was designed like a storefront more similar to the first example would not be appropriate in this one because of the later period and style of the building. So this storefront is constructed with metal framing instead of wood. Gives it a much lighter, more delicate appearance, and the bulkhead is stone with some visible vents. And the overall emphasis of the bottom one is much more horizontal, which is compatible to that building. Here's an example of a late 19th century masonry building, and the storefronts have been infilled in the 70s with curved brick piers and plate glass windows, stacked bond brick veneer between piers. Certainly not appropriate to what the historic building would have had. This is what was constructed as a replacement for a non-historic storefront system. And this is a case where the design and proportions are pretty right, but the finish of the materials leaves something to be desired. The final result could be improved if the historic cast iron columns and exposed steel beam and lintel across the top of the opening were painted a consistent color rather than leaving this kind of half-painted deteriorated finish. Also, the doors should have all been painted as well in the framing around. In this example, it's a building with non-historic replacement storefronts, but we have photographic evidence to show the historic configuration of the building. And it had, you can see here, it had a series of tenant spaces with recessed central entries. The image at the lower left shows what the project was at the start. So certainly it had come a long way from what it was originally. The new design for replacement storefronts, the architect was attempting to reference the historic configuration without actually replicating what was there. So we see that they're trying to simulate that they're where those central entries were, and we end up with these additional vertical mullions that create these odd small pieces of glass within the storefront, which is an incompatible configuration. So in consultation with our office, they had cleaned that up a little bit, removed the extra vertical mullions that weren't necessary, widened those into a three-part display window system that was appropriately proportioned, and the new storefronts at the end of the day are compatible new features. And you see at the top there, it turned out very nice compared to where we were at the start of the project. So a little bit of tweaking. Again, we're not forcing people to restore, even though we have a historic image. It just has to be compatible if it's missing. But you do have to be careful about what compatible means and how those details actually lay out on paper. We often see some applicants wanting to introduce operable storefront systems within their projects. Operability is not by itself necessarily problematic. As a reminder, some historic storefronts were designed so that all the bays could be open, like this project here. This is from a project in Galveston, Texas, I believe. So in thinking about new compatible storefronts, the most important factor that we consider here in our office is that when a storefront is closed, the design must either match the historic configuration or be compatible to the historic building. This is an example of an operable storefront that is quite clever. And from the exterior, it just looks like a regular traditional compatible storefront system. But in reality, these display windows actually slide up behind the transom and they actually open and are operable. When they're closed, though, they look like they should be. They're well proportioned, they're well designed, they're well detailed. And anyone passing by this would not know this was an operable system unless they saw that essentially very large sash slid up behind that transom. Sliding windows are not compatible because the glass and frames by necessity are offset and staggered. You can see here that the way they slide and stack open creates this offset configuration. They often result in tall, narrow window configurations as well. So overall, these are typically not compatible solutions for operable storefronts, and this would not meet the standards. NanoWall is another popular specific system. Again, we end up with these more narrow proportions, tall, lack of a bulkhead, incompatible framing details. They have kind of seams and grooves that are visible down the front of these. So operability is a concern in how it's detailed. Oftentimes what we see available are not solutions that would meet the standards. It's more appropriate for inside of a mall really than the front facade of their primary elevation of a building. Here's another example of an operable door system where they have a bifold or even a roll-up garage door. So stepping back, if you look at the image in the upper right-hand corner, you can see that the building features, nice architectural detail, and it's a fairly large-scale commercial building within the urban setting. So when it's closed, these storefronts, if you look at the image on the bottom of the screen, these storefronts appear much more like garage doors. They have a horizontal grid with heavy framing members, and these create a proportion that are not consistent with what a typical storefront, again, would be. So in this case, the operability is incompatible. This treatment would not meet the standards. When designing new storefronts, we encourage careful attention to be paid to the construction details and materials themselves. Unfortunately, new wood storefronts aren't as comparable to their historic counterparts. We all know the challenge of modern lumber versus historic, and the potential for decay and deterioration a lot sooner. Just some examples of where we start to see those issues come up in some historic storefronts. So think about materials. This is an example where new wood storefronts were constructed, but they weren't properly detailed in the construction process. They did not prime any of the individual elements or end grain of these boards. So in the upper left, you see they constructed it and then they painted it. And then on the lower right, you see what happened. This is the same storefront, that same corner, only just 2 or 3 years later. So be mindful of construction details and how you're working through these replacements as well. Panels should be constructed rather than applied or glued on. You can see in that left image, they had just tacked the panel on, it's now peeling off the face of that bulkhead. Substitute materials may be a good option for many storefronts, depending on the situation and project. When considering the use of a substitute material, it's important to have a thorough understanding of the material properties, as well as critically evaluate their appearance, especially because you're at ground level, you're at eye level. You'd have more scrutiny applied to that because these are things that you're interacting with and even being able to touch at ground level. In the image on the right, just note, caulk is not a solution for poor construction and should be used sparingly. We see this a lot where people try and fix perhaps some poor construction details, and within a short period of time, we see that fail as well. So additional guidance is available through our website. Kim mentioned earlier, we have a lot of things on our website. It can be kind of a maze to navigate, but there's a lot of good stuff there. So please, if you haven't, take time to look through all of those and read through those documents. Preservation Brief 11 and some ITS. So when we say ITS, that's interpreting the standards, and there's a number of bulletins, and we linked to those earlier this morning in the chat box as well. So take a look at all of that. So that ends the storefronts, and let me shift over now to windows. And you guys should be seeing the window presentation. If not, please holler, but I will roll right through this. So this is where we start to get a little bit more
David.
Thank you, Michael. We get to a little bit more technical here. Please bear with me. There's a lot of images. I want to kind of just get your eyes on so you get an idea of what we're looking at and how we review windows. And I'll just try and be as efficient as possible in this. So any determination about what to do with windows in any rehabilitation project always has to start with evaluating what is there, what is existing. In this case, we have historic windows left. Condition might certainly be a question, but the starting point is, what do we have? We have a historic building with existing historic windows. There's a full spectrum of challenges that come with windows. In this case, for this project, you'd be starting with the fact that historic windows do remain. On the other side of that, we have a lot of projects where historic windows are long gone. They have non-historic replacements or even significant modification within what you can see as the historic openings. Here you can see a lot of the large window openings have been blocked down for these inappropriate sized double hung. So these would certainly all be able to be replaced without much concern. And then we'll talk about what that means to replace and what those details are and why all of that is important. So evaluation, what are you starting with? That's always question one. In context of review, according to our standards, again, for anybody not familiar with our program necessarily, we have 10 standards, Secretary of the Interior standards for rehabilitation. In looking specifically at windows, we can look to standard 6 and 2. Number 6, referencing deteriorated historic features that shall be repaired rather than replaced. This also includes text about where the severity of deterioration requires replacement. That at least acknowledges that replacement may be necessary, and that's certainly a question that we can get to in that review process. And according to standard 2, removal of historic materials that characterize a property must be avoided. So if we have historic windows and the proposal is to replace, we'll review those in context of the standards. Again, standards 6 and 2, the replacement of a distinctive feature must match. And according to standard 2, do not alter features that characterize the property. So that comes into play more with those. If you have non-historic windows that are being replaced, standard 9 comes into play where new work shall be compatible. Again, we talked about that with the storefronts. Windows would be the same. If there's nothing there, nothing's historic, the new ones just have to be compatible to that specific building. Windows vary in their importance. And while the windows in most historic buildings make a significant contribution to their character, all windows are not equally important to the historic character of all historic buildings in the same, I guess, the same frame. Not to make a pun there, but so on the left here, you can see that window, that building is nothing but windows. That is a industrial building with industrial steel windows, and that is the character of that building. On the right, we have a more windows that are inset within heavily articulated architectural detail. and sit more in shadow. And so not saying those windows aren't important, they certainly are, but take a look at what the specific character is of the building and what how those windows play a part in that. Hierarchies depend on the size and scale of a building. At the base of very tall buildings, both the details as well as materials are important to the match of replacements. Typical windows on upper floors may warrant the use of a substitute material such as aluminum or aluminum clad wood windows, where you have repetitive floor plans at a high level. Here you can see the difference between fenestration at a base of a high-rise building and then looking up at the actual full shaft of the building and seeing, take a moment to acknowledge how you experience these windows based on scale and hierarchy. And then the image on the far right, if you have windows on a secondary elevation or against an alley, there might be more flexibility with those. They're not as distinctive. They're not as visible. So hierarchy is important when assessing what to do with windows, as well as location. Significant interiors, when there are interior spaces that have distinct character that should be preserved, the effect of the window on that character must also be taken into account. In some cases, this might require materials and details that would not be needed if the replacement were to be evaluated from the outside alone. So here we're seeing that both sides of the window do matter depending on the project and the building. Take a note of the negative impact of the white aluminum or vinyl in these cases on the interior character of this building or these particular rooms. So even extremely deteriorated windows can be repaired. This might look a bit daunting, but beyond a certain point, repair may not be reasonable or practical. We acknowledge that, but never say never. People with enough effort and perhaps money can certainly make anything happen. The level of deterioration is important, though, as we start to assess these. So the true condition of a window may be concealed by peeling paint and missing putty, and those things are easily corrected. Even severely weathered surfaces and pockets of decay may be repaired with treatments such as modern epoxies, but it's most reasonable to make this sort of repair only if it involves pretty limited areas. If you have a lot of windows with the same repetitive issues, that might not make sense to go that route, and replacement might be warranted. When we evaluate windows for repair or replacement, deterioration should be the primary concern in evaluation of those. And though there can be other factors to take into account, note that the desire for easier maintenance is not justification alone for replacing windows. We often see that. People wanting to shift from wood to aluminum just because it's easier to maintain. There's a lot of other factors we have to look at before you can make that decision. So some of those contributing issues that we consider include, or I should say, they help determine the practicality of retaining and repairing windows in conjunction with deterioration. And so these include operation, depending on the new use of a building, hazardous materials, perhaps with lead paint or asbestos glazing compound, code requirements for life safety, whether it be fire code or egress out of residential use. Energy performance is the most common desire in new windows that we see in applications, and that's certainly something that we have to consider. So typically, a full, detailed, extensive window survey is not always necessary. Kim mentioned earlier that there may be situations where we do ask for that. It depends on the building and what's happening. But for every project, we don't typically require that. But we do need adequate photographic documentation, both interior and exterior. It's important to show both sides of the window. Exterior window, the exterior side window might have significantly different conditions than what's happening on the interior. So it's important for us to know what's happening on both sides. Photographs should be keyed to plans or elevations. Look what existing conditions there are. There's storm windows on the building right now that are helping protect windows. If so, though the condition of those windows underneath might be in better shape than ones that don't have those. And it's easy to look at peeling paint and cracked putty and say, oh, these windows have to go, but there's a lot more to it than that. So look beyond more of the superficial characteristics and conditions. Just for reference, this is an example of a window survey, a very thorough window survey. If you ever need to do one or want to do one, where you're both highlighting on drawings as well as in written descriptions of what these conditions are and quantifying those on all elevations. But regardless, photos are key here. We need really, really good photos. So photos just standing a mile away looking at the exterior of the building are not going to help us. So, get that telephoto lens out on the exterior, get up close to the windows on the interior, and really help us understand what is happening with these. Because unfortunately, as much as I would love to be, I can't get out there and see all these buildings in person. So I really rely on you all to put together that information to help us review this and help you through the application process. Here's just a quick list of, as we start to assess windows and all the pieces and parts that go into it, what we start to look at. We've already talked about some of these. Here's some photos that show conditions that do not warrant replacement. So on the far left, you have some peeling paint. It's very superficial. You can scrape that and repaint it, and it's good to go. The middle image shows cracked or missing glazing putty that can be easily repaired. And on the upper right, you see broken glass. That's also easily repaired. So these might look a little bit scary or daunting at first, but when you take a closer look, these are repairable conditions. Same thing. So broken sash cords, ropes, chains, that's something can be fixed. And the image on the right looks like there's more structural damage, but in reality, it's really just the parting bead that likely would be pulled out anyways when repairing these windows. And that's something you could easily get today at a lumber yard to replace that. So take a careful look at what you have there and give us good documentation to show us what these conditions are. Here's a situation where you have historic windows and you want to improve thermal performance, and the window itself is in good shape. There's really no need to replace. Then we would suggest you explore adding a storm window, whether it be exterior or interior, especially on a window with distinctive characteristics. We see a lot of success in this, in not only preserving the window as historic fabric, but also if you do exterior storm windows, it can help protect that window for a much longer lifespan moving forward. So always consider those. Here's on an industrial building, you can see they used storm windows on the interior. They did not need to operate the window, so we were able to retain the historic steel windows while improving energy efficiency for the overall building. Now, there are situations where we look at these and say, yeah, these are just way too far gone. There's no denying that we have physical conditions that warrant replacement. And this is some example of sash failures. You can see that the mortise and tenon joints have failed. The sash components are actually coming apart. This would warrant replacement typically in our perspective. Here's some other examples. If you take a closer look, where you see some more structural issues happening with the sash. The bottom image, they've actually added a metal L bracket to try and hold that together. Take a look at the sills. Are the bottom rails of sash meeting the sills? Or is there dry rot happening? How extensive is that? Where is it? Is it repairable? Is it not? Sash fit is important. Sometimes this is just a buildup of paint over years to where the meeting rails don't quite meet each other anymore. You can see in the upper right image, or they don't quite sit flush again with that sill. Perhaps this is more of an easy solution by stripping paint, but there might also be more structural things at play. So take a look at that. These are all details that are helpful to know. Wood decay is inevitable in some places, especially certain parts of the country. That's pretty easy to identify in your projects. Here we have examples of both the wood sash themselves having wood decay, as well as the sills and jambs surrounding that. Here's one that is so bad you could shove a pen down into that joint, and that's a critical joint in the structure of the jamb. The image on the right, you can see we've lost a lot of a profile section in that, and if you were to try and screw anything into that, it would just go right through or even fall off the face of what solid structure remains. So detail photos, I think that's the key thing here in these images, is look at how much information you can share with us by giving these detailed photos as part of your application. If we look at steel windows, we typically look for loss of section in steel to warrant replacement. General surface rust isn't always a warrant to fully replace a window system. that is something that can be relatively easily fixed. But in this case, you can see there's absolute loss of section here. These steel windows have been rusting, and these are certainly beyond repair to the point of replacement. Also, in steel windows, we start to have structural issues. Here's some rust jacking that has caused significant failure in both the masonry below the window as well as the window structure itself. So this would certainly be a window that would be need to be replaced. So if we start to then look at understanding replacement, what is exactly being proposed for replacement? And sometimes replacing less might, the intention is good, that you're trying not to touch as many things, but it isn't always better. And we'll take a look at why. And then the question is, how will the replacements be installed if we do agree that replacement is necessary? Are there compromises that we're going to have to come to based on the available manufactured units and the type of window that you're needing to put in the building? How does that material affect the match? And then based on all of these, then we can judge on what matters most in these window components. Just a quick side note, we see a lot of projects that do retrofit existing historic windows with insulated glazing units. It's not impossible. It's certainly doable in various types of windows, so always something to keep in the back of your mind. But let's take a look at, let's get into actual window replacement and what these start to look like and why we need to be cautious about these and careful in the details. Here is an example of substantial changes in dimension and profile of the elements that both the frame and the window sash itself can have on the impact of a window's character and overall building. The left is a historic window and the right is a replacement. And take a look, you can visually see the difference between these. The one on the right is much more bulky. Those proportions and dimensions have changed versus the original historic one on the left. Let's take a look at what each of these main three components are. If we're looking at wood windows, there are three basic things that we look at. It's the sash, highlighted here in green, and you can see where that sits in the section. Next comes the blind stop, which is historically the small piece that held the sash in place, and that runs all the way around three sides of the window. And then the brick mold, which is the outermost trim part, which is where the decoration tends to come. These are typically profiled, they can be stepped, depends on the window. But when we talk about a basic compatible three-part configuration, this is what we're referencing: the sash, the blind stop, the brick mold. So let's say you only need to replace the sash. If the jamb and the frame is all sound, but the sash are rotted, you can certainly have new sash manufactured. In this case, the sill should still be repairable, so you get a nice clean fit at the bottom of the window. Advantages to this is you keep a lot of historic material, insulated glass may be introduced, and there's no disruption to historic trim both on the inside and outside of the building. So it can be a very ideal solution depending on the building. Other ways of introducing new sash are what we call sash packs, where it's a manufactured system of vinyl jam liner with two new sash that slide up and down on that. The advantage is, again, similar to reconstructing true sash, would be you can get insulated glazing, still no disruption to inside exterior trim. Just note that there are some visual things that happen with those jam liners, so keep that in mind if you are exploring sash tracks. And dimensions might not be as customizable perhaps as a true reconstructed wood sash. Other times we see people proposing just a full new unit, which would then the entire thing would slide inside of the remnants of the jam or framing that's remaining from the historic windows. You have to be careful about this because they can start to skew some proportions. They have a more visual impact. And this is what we refer to as an insert unit. And so this is the big question we always want to know is, are you proposing an insert or are you proposing a rough masonry opening install? And a lot of times it's hard to get that information out of people because maybe you haven't thought through the installation all the way yet. The pro to these is they're inexpensive. It does keep trim in place. But the con is that they have some significant compromise in those proportions and dimensions, as I mentioned. So you have to take a look at the specific project and building. Maybe an insert unit is a viable compromise. A lot of times it might not be because of the visual impact that it has. Here's some examples of an insert. You can see it's very, very clearly a new window that sits inside the historic frame components and trim. And so it does modify the character of those window openings. And then we have a bunch of these on, large primary elevations. It does have greater effect. This is what we refer to as a rough opening replacement or rough opening installation. And here you see that these windows are much better fit to the opening, and they typically replicate that 3-part configuration, the blind stop, the brick mold, and then the appropriate sash reveal. And this just gets a better fit to that window. So a lot of times, there are projects where you may be proposing to do a insert, but it might not be appropriate, and you need to explore what it would entail to do an actual rough opening installation. So the big question as we're reviewing replacement windows is, does it match? If you have historic wood windows and you're proposing replacement, they need to match. And in order to assess that, we need to have good drawings that compare these systems side by side, both in vertical and horizontal sections. They need to have the appropriate details and dimensions. So here you can, this is just a quick mock-up showing you all those components and the dimensions that we would be looking for both the existing window as well as the proposed, to then make a determination on the appropriateness of the replacement and match. And here you have so both the vertical, again, as a horizontal section, you can see at the jamb, and both the head all the way through the sill of the window. Let's take a look at the sash components specifically, or the window components. We'll start with the sash. In this case, you can see on the far left, this is a typical sash where you have even proportions around the top and the sides of the window. There was consistency there, and you have a nice proportion to that window. You can see the replacements on the right. We start to skew those a bit depending on the particular window. In this one, we have a very narrow top rail, which is different from the dimension of these side stiles. And so we lose that proportionality of the window all the way around. Here again, we have a very wide style compared to a narrower top rail. So things to keep in mind: sash proportion and what is visible from the exterior is important. Looking at the blind stop, again, it's a small element within the overall window assembly, but it is noticeable as part of the frame profile. And part of the noticeable difference between the historic window on the left and the two replacements on the right is due to that blind stop configuration, or even a simulated blind stop configuration. So it looks small in a drawing, but it is an important component to windows. And then the brick mold, again, this is the outermost part that can be stepped, it can be curved and profiled, and it's very distinctive in defining the character of a historic window. So if you are doing a replacement, the expectation is that the new brick mold would match that profile to the best ability possible. But there's limitations, as you shift to other materials apart from wood, there are limitations on the details and profiles that you can get. But I will say we are getting a lot better products on the market available these days than I think we saw for many years in this program. So if we put everything together and look at all these elements and add them up when viewing this particular replacement window, here we have a great example of a side-by-side. The one on the right is the historic, the one on the left is the replacement. Take a look at the upper left corner of the window in that shadow. It perfectly timed shadow for this photo. It helps us see that 3-part configuration of the historic window: brick mold, small blind stop, and then the sash reveal. On the replacement, you see how we have a window that has this kind of cascading effect of a lot more profiles and steps than what matches the historic. So all these elements are important in this and do have an overall cumulative effect, even in the window design itself, in order to find an appropriate match. So keep all these in mind. These are what we're looking for, and this can get very technical. If we were all sitting in the room together, I'm sure I'd see all your eyes glazed over at this point. But the important thing here is that there are visual distinctions that happen with replacements, and this is what we need to be careful about and consider when we're making the decision, as in terms of what's the best solution and what the best product might be. Again, here's an example of where that top rail is very, very narrow. You can see the historic on the left in the drawing, and then what the proposed was. That's a big difference between those two. And then looking up the window, it might not make as big of a difference, but it does end up being substantial. some smaller details I want to move through quickly here. Muntins are important, not only the shape, but the depth as well. You can see in the image in the middle where that person's holding the proposed muntin up against the historic. Look at the difference in that profile and depth. And that does have a visual impact. And you can see that in the drawing. On the left at the top, you see the historic, and then below it, you can see an example of when insulated glass is retrofit in a true divided light, and you got to beef those up to hold that glass. So there is a visual importance to the muntins as well as the overall sash components and framing of the window unit. Simulated divided lights are the industry term for a three-part assembly, which consists of of a three-dimensional external grid applied to the exterior of the window, and then there's an interior spacer bar between the glass, and then there's another grid applied to the interior face of the glass. We have a three-part simulated divided light. It allows for the two pieces of glass for the insulated glazing unit, but what we get is the simulation that true divided light is still there in the replacement window. It allows for greater flexibility in muntin size and profile, and it can be effective imitation when that component is characteristic to the window and needs to be carefully executed. We regularly approve simulated divided lights and replacement windows. Looking at steel windows, these often were embedded in masonry wall systems as constructed. So any replacement, keep in mind, we're just going to get a bulkier window. That's just the fact of it, because of how a steel window system was made and installed versus a replacement aluminum. Some manufacturers do it better than others. So those are the details we would look at is, are we getting the most minimal dimensions possible or most appropriate versus some that are still more bulkier and inappropriate in dimension and profile. With the replacement of steel windows comes the need for structural muntins. You can see those running across those windows, and that is to hold up the operable vent. That can't be done in any other way in replacement windows. So you have to take a careful look at how that's detailed, because it can have a impact to the exterior character of the building. And again, going back to the muntins, here's some examples of different styles, where the top left one was just a flat one applied, which does not have much depth or shadow to it. The one on the right here has some metal strips applied to give it that three-dimensionality. And then on the lower left, you see a more traditional three-dimensional profile of a historic industrial sash. So these small details can add up and have significant impact. If you use applied muntins, they must not be obviously fake. In this case, these ones are bowing from the exterior glass. And so that's obviously a very poorly constructed simulated light. Here we only have the interior spacer, so you don't have that three-dimensionality in the exterior expression of the division. Mullion details are also important. Again, I'm trying to just kind of move through these quickly here, but because I'm already getting tight on time. But take a look at mullions. How do these interact with windows on either side of them? How do you detail those in replacements? Are you retaining? Are you replacing? That all has to be accounted for within proposed window systems. Transoms, you can see here, these are very three-dimensional. If you have a three-dimensional, you have a transom window above the hung window below. And there was function to this. These were meant to shed water in front of the hung window. And so that is all part of the character of that system. So here's a replacement where you see how flat that transom division was made. And you can see an overlay in the image, in the middle image, where we see the historic drawing overlaid with the constructed, and you see how flat that was compared to the historic. So that does change the appearance and the character. Materials, I have a couple things left here. Materials, new windows that use substitute materials not only have different finishes, but they also can have different profiles and dimensions from the traditional wood, just because they're made different. They have different assemblies and components. So those are things you have to take into consideration when proposing a replacement. And they can either make a window appropriate or not appropriate, depending on what limitations they have. And last thing I'll talk about is the glass. Obviously, a window isn't a window without glass in it. So with the exception of stained glass, prior to the mid-20th century, glass was almost always clear. So the use of any reflective or tinted glass as a replacement typically is inappropriate and changes the historic character of the building. And you see that reflectivity on the right, you can see these are very reflective windows that are not appropriate versus a clear glazing where you can see into the building. Tinted glass did become popular in the mid-century. And so if there is a historic tinted glass, keep in mind that a replacement would have to actually be dealing with the match of that rather than just going for a clear glazing replacement. Not all glass is equal, and this is just an example of some details that we look at. So NPS typically requires clear glass with a minimum visual light transmittance of 70% or higher. We can talk about those details on a case-by-case basis if you want to get into that, but just take a note of this. And there's a difference in glass, there's a difference in color based on the type of coatings that are used in this and the type of glass. So these are all things to keep in mind. I know this is a lot of technical details, but that's what goes into review from our end on replacement windows. And I am quickly running out of time, so I'm going to jump over to rooftop additions. And let me run through this one. Uh-oh. Let me start back there. All right, so rooftop additions, these can have significant impact to a building. As we see in this example here, there are several issues that we look at with rooftops, additions themselves in terms of usable square footage, parapets and railings that come with them, and last but not least, we can't forget about any HVAC equipment that goes up there as well. In terms of guidance, we have a lot of published guidance on our website. Again, please take a look. We have various ITSs as well as a white paper specific to rooftop additions, as well as general guidance for additions in any capacity. So we have to look at the historic character of a building. We have to look at the existing conditions of a building, as well as the visibility to determine if a proposed rooftop addition, will it affect the character of the building? That's the big question. In terms of standards, we can look to standard 9 and 10 in terms of what is appropriate and how we must review this in context of our program. New additions shall not destroy historic materials. They need to be differentiated yet compatible. There's that compatible word again. It's very important. And then standard 10 references that new additions shall be undertaken in a manner that if in the future they're removed, they don't necessarily, there's a reversibility component to that. You're not damaging the historic property and its environment. The integrity is left intact if you were to remove it. Now, a note on reversibility, that does not mean a change is acceptable just because it's reversible. And it must be reversed without harming the historic building. But even if it's reversible, it must also be compatible. So I think people kind of get caught up in that word reversibility as a means of justifying things, but keep that in mind. All right, so let's get into rooftops. Our guidance, our white paper guidance on this has 5 questions that we ask when we're assessing rooftop additions. And these are them. Number 1, can the historic building accept a rooftop addition at all? Is this the type of building that can handle it? Number 2, from what vantage points is it appropriate to evaluate the rooftop? You know, how far away can we actually look at these? Number 3, if a rooftop is determined to be appropriate, where should it be placed? You know, can it take up the full footprint, or does it need to be localized somewhere within that building footprint? Number 4, how much should a rooftop addition be set back? And lastly, how should a rooftop addition make clear between the historic building and what is new? How do you walk that line of compatibility? So here's a 3-story building that has a 1.5-story-ish addition on top of it. It's also designed that is not compatible. This is just a scale of building that should not be really getting a rooftop addition. Generally speaking, rooftop additions are not appropriate for buildings less than 4 stories tall. Additions to buildings of that size can dramatically change the massing and as a result change the historic character of the building. So this image shows again, that 1 story or 1.5-ish on 3 stories. This does not meet the standards. This 3-story addition on a 12-story building is incompatible due to its size and placement, as well as the detailing of it. While it's simple and perhaps a 1-story addition would be appropriate, but this is, again, multiple stories. The addition negatively impacts the character of the historic building. This one does not meet the standards. This is a 1920s mid-rise hotel building. It's on a corner lot. It has a shallow floor plate. There's a very distinctive roof line and cornice to it that tops the building. Here is an unfortunate addition that was constructed. This does not meet the standards. It's not compatible with the massing or size and scale of the building, nor the architectural features of that historic building that was capped with that cornice. Perhaps a smaller rooftop addition, no taller than 1 story and pulled back from the edge of the building, could have been appropriate with more compatible materials as well. So the next question, where is it appropriate to evaluate the impact of a roof addition? Distance is dictated by visibility. I will say there's no set dimension. It's not like, oh, anything beyond 500 feet or a block, we don't care or don't look at that. That's not true. Depending on the type of building and the size of addition is going to dictate where we need to go to look at that. And in this case, it's not appropriate to evaluate the impact of an addition from privately owned empty lots surrounding it. That's not the case in this one here. But we go by public right of way. So wherever we can be on streets or sidewalks, looking through parks or across parking lots, that is all fair game, but we would not go either onto adjacent buildings and look down on the addition or stand in private buildable lots next to it and start saying, making review decisions from there. This is an important slide just to note the significance of multiple vantage points when assessing visibility. So the image on the upper left is what we first got when someone was proposing a rooftop addition and said, look, we can't see this. We're standing in front of the building and you can't see anything up there. Well, that's great. But what happens when we move down the street or around the corner a little bit? Well, suddenly, if you look at the lower right image, you see, well, that's quite visible. And so it's important to note that distance is a major factor in determining appropriateness for rooftops. And this configuration was determined not to meet the standards. Here's an example of, you got to go in all directions. So the red rectangle here is the historic building, and these are all the vantage points that photographs were taken to look and assess the visibility of any proposed mock-up. So it's not just specific to the address street. You got to go in all directions and really show us the potential impact of that addition. So if we do determine that a addition is appropriate, where should it be placed? And in this case, the guidelines recommend setting the addition back from the wall planes to help it as inconspicuous as possible. Setbacks should be considered for all elevations that can be readily seen. In this case, it's a 4-story commercial building with a 1-story rooftop addition that was set back almost halfway from the front facade, which makes it very minimally visible. High party walls on either side also help to reduce the impact. The addition does not change the character of this historic building. In terms of how far to set back, there's no formula for how far an addition should be set back or looking at it from the ground. For low-rise buildings, it should be set far enough from the facade to make it inconspicuous. For medium-rise buildings, maybe some visibility would be acceptable as long as it doesn't negatively impact the historic character of the building. And for districts with wide streets or parks, moderately scaled buildings, you may need to have a greater setback. And in this case, it's a high-rise building that has an offset that is sufficiently back from the street, though still visible. You can respect the historic character of the building in assessing those two between that. So I think this one is sufficiently set back. It reads more as like a rooftop pop-up rather than a full addition to the building. In this case, in elevation drawing, this was a proposal to go, full footprint of the building, which clearly is not appropriate. This is too impactful. And even though we don't have the sightline studies, we can already tell that this would be very visible if we're building out to the building's edge. This is a corner building that had visibility on all sides. It has a simple roof line. The proposed addition is pulled back from the edges of the building and is not very visible from the surrounding district at all. But in this case, perhaps more information may be necessary to determine that. Here's an example of a building that has a completed addition, and look at the articulation of the architecture. So you have multiple primary facades and one clearly secondary facade. Although visible, it's distinctly different from the other elevations. And so in this case, it was determined that a small rooftop addition could be built to that edge because it blended with both the materials and color with that secondary elevation to what expression was already happening up there on the historic building. And here's an example of what these look like up there. There's a setback, limiting privacy walls, using parapets to help screen these with sufficient setback, using materials and color palettes to help minimize that. The question of how to distinguish between the new and old, again, that keyword compatibility. Here's an example where, these are quite contemporary additions and designs that are happening up there, and they're clearly differentiated, almost to the point of distraction, unfortunately. These were both determined not to be appropriate. Something smaller setback, in this case, these large overhangs and eaves, a very modern contemporary articulation, needed to be revised in order to achieve greater compatibility with the historic building that it was on top of. On the other end of the spectrum, when we're evaluating a proposed rooftop addition, the existing character defining elements of this historic building have to be considered and how they would be affected by a new addition. This is very intricately detailed at the top of the building. In this case, that cornice has been compromised with the two-story rooftop addition that has no setback. This example also brings into question what is historic and what is new. It really blurs that line. They're picking up on a lot of historic details. So from afar, you start to wonder if this had always been there versus a very inappropriate two-story addition with very little setback. In terms of documentation that we need at the Park Service to evaluate proposed rooftop additions, physical mock-ups, photographs again are key in conveying any sort of visibility or impact to the building. Sightline studies, elevation and section drawings. We see a lot of computer digital renderings, renderings overlaid on photographs, always with site plans and maps, which are important. Here's an example of a computer-generated model that could assist in conveying that addition. In this case, we probably would need more information. We want more sight lines from farther away. This one alone, sure, we might catch the top of it, but if we start to walk up and down the street, how much more do we start to see? More information would be needed in this case. It's important to note that sometimes renderings and sightline drawings can be deceiving, and actual mock-ups might be required for review. In the rendering on the left, the addition appears less visible than it was when it was built, which you see on the right. There's a pretty big difference between those two images. In this case, the building is across from a public park as well, with direct views of the roof and the rooftop. So this rooftop addition does not meet the standards, and we would have significant issues. Let's say the rendering was approved and the completed project came in with this here that had substantial deviation from the proposed drawings. This could very much end up in a denial of the entire project due to inaccuracies between what was reviewed in the design process to what was constructed. It's often hard to tell how accurate a 2D sightline study is when viewing or reviewing a proposed addition. This example is from that same project or the previous slide, and you see how this is only showing us standing on the ground. And in this case, you wouldn't expect to see a whole lot. But again, once you go down that street and look three-dimensionally, it's a whole different expression to that. Mock-ups can be done very simply as well. Here's just examples of using 2x4 timber framing, just framing out the basic massing of the proposed addition, wrapping it in orange snow fence, and then going and taking photos of it from the ground where necessary. In this case, it was a very minimal, more penthouse type situation. On this building, it was no issue. They proved that the sight line, you could see it, but it was minimal and gave us confidence that what they were showing us is what would actually be built. This is a substantial mock-up that clearly shows the location and size of the proposed addition and is very helpful in evaluating the effects of that new addition. You don't always have to go and do a full frame out like this. This is just an example of a project that did, and it's very helpful. Here's an example of a mock-up made by a person on the roof holding a pole that then digitally filled in later with those points. These are easily done for small scale pop-ups as well. If that's more something you're inclined to do, that's fine. For larger scale additions, it may not be possible to create a full mock-up of all the wall surfaces. In this case, This shows a combination of both a physical mock-up as well as a computer-generated color overlay, which creates a realistic representation of what we would be getting. And in this case, this was determined to be too large, too visible, and inappropriate for this scale building. This is an example of using a computer rendering and overlay on photographs, matching the same viewpoints to each other to highlight that visibility. This is very helpful. This is another example of why it is important to document visibility as you move away from the building, because as you can see, visibility certainly changes. So that's always important, keeping distance and sight lines in mind. And any proposed rooftop addition with sightline studies needs to have a map or a photo key showing us where exactly these viewpoints are taken from. And if they are insufficient, we will likely request additional studies are done to give us the confidence that what is being proposed is minimally impactful to the building. A few things to wrap up here. I do want to talk about railings briefly. Railings might seem inconsequential, but they really can be highly visible depending on the building and the roof system. Railings are typically necessary for either patios or decks, pools, mechanical access, mechanical platforms. This is an example of an incompatible railing. It's at the edge of the building. It's very tall. It almost looks like a prison yard up there. These should be set back. Utilize parapets to the best of your ability, depending on the building. Here's one that had no parapets, and the railing is certainly smaller and less intrusive, but it still is an incompatible railing system because it's at the edge of the building. It's highly visible. And in this case, we also have a likely an incompatible addition on the building as well. Railings can have impact just as much as the physical addition itself. This is an example of a good compatible railing system where they angled the railing backwards behind a parapet. So standing on the ground, it helped minimize the visibility of that top rail edge while providing code compliance. So that's a good example. Glass railings can be very beneficial, especially on large scale projects. At the top of these buildings, you would never know this glass is there. The one thing I will say though is glass is not invisible. So on lower scale buildings, there's still a reflectivity component to it. Even if it's glass, it doesn't mean they're invisible and always compatible. So keep that in mind. This can be a very good solution depending on the scale of building. And HVAC, let's not forget that. This is often kind of something that gets left out of applications and then suddenly shows up in the part 3 photographs we had to deal with at the end of the project after everything else is said and done. Be mindful of these. We should know about these details up front. I mean, look at the impact of this on a church building, both the access penthouse as well as the mechanical platform itself. Again, utilize the architecture of the building to your advantage. This has a parapet that isn't solid, but it certainly helps screen any of these mechanical systems that are up there. In this case, it was a taller solid parapet, which gives a lot of flexibility on loading those flat roofs with the equipment necessary to support the new rehab use. Scale matters. On the left, you have a small scale building with a very large mechanical platform, obviously an incompatible treatment. On the right, you see examples of a dense urban environment with flat roofs, parapets, and those can support very large systems. So scale plays an important role in assessing that as well. Here's an example of a building that was proposing an addition as well as rooftop mechanicals. And in this case, we had a tall addition, but then in the review process, they didn't necessarily share with us that these mechanicals were proposed to go on top of the addition. So we have essentially 2 layers of things happening to this building. And when you look at this in a sightline study in 3D, you can see how impactful that really is. Not only the addition itself, we almost have this elephant trunk sitting on top of it. And this project was ultimately denied because of all of this happening up there. So the HVAC details are important, and they should come early in the process as soon as possible. And you should share these as part of the sightline studies, as well as elevation drawings, mechanical plans, because they can make or break a situation. But some historic sites or buildings have a lot of flexibility. And in large industrial complexes, the very nature of them were industrial with large mechanical systems on the roof, on the ground, all over the place. And that's the character of them. So in that case, putting new systems and rooftop equipment may not be much of an issue at all. In fact, it probably would be in line with the historic treatments of the property. So again, it just depends on the type of building and the type of property. This is the last thing I'm throwing in here. I'm basically out of time, but this is real. This is here in DC. This is just for fun. I wanted to show you when people say, well, what's the big deal? I mean, can a rooftop addition, can it really be that bad? The answer is yes, because look at this poor thing. These are two-story row houses here in Washington, DC. And this was a rooftop addition that added, I think, 4 stories to the building and also was basically eating the facade of it as well. And this is it completed. And so if you look at it in the streetscape, additions can have a substantial impact to the historic character of the building. This poor guy, you see his corners barely hanging on there with this thing sitting on his shoulders now. Also note in this image, again, railings and penthouses and pop-ups and what this starts to look like and how impactful these can be on rooftops. So these are treatments that we often get asked questions about. We see proposals for. It's important to look at these details early and have all that information up front to avoid delay in review, or even worse, to end up with problems in achieving certification at the end of the project. And here's just a quick recap on what our white paper guidance is, but that is everything. I appreciate you guys sticking with me. I know that was a lot to push through here in a short amount of time. So that's it from me, Kim. If we want to open up for questions, I'd be happy to take those.
David, thank you so much. I learned a ton, but I hope will help everyone have good projects. So thank you. I really appreciate it. And I really appreciate Michael and Nicholas's wonderful comments. We all work together to help you guys make good projects. So please raise your hand if you have a question, or feel free to type in the chat. We've got 15 minutes carved out here for questions. So lots of thank yous in the chat and stuff. Yeah, that rooftop addition, that last one, that was a good time, wasn't it? It's got a little cornice poking out under its little shoulder.
And that's sad. It's one of those things you have to just shake your head. You can't even believe it's real.
Yeah, so copies of PowerPoints. I think David is okay with sharing the PowerPoint in PDF form on the website.
Yeah, I can get that for everybody.
Okay, so Michael's and mine, of course, will be on the website as well. And then I have recorded the presentation. I will probably break it up into several different videos and put it on our YouTube channel. So look out for that. Is there any questions? Must have questions for David.
They're just overwhelmed.
Okay. All right, here's one. On rooftop additions, how do you consider topography? An addition could be minimally visible from certain vantage points, but then very visible from up a hill. We have lots of hilly streets in Seattle.
Yeah, great point. No, that's definitely something we do take into account, and you have to, because you look at the site conditions of the building, and let's say it's more visible from a secondary elevation because perhaps the topography rises to the back of the building and then you're getting more view from it there, or vice versa. Maybe that would be more acceptable to see more of it on the back side of a building. But if it's primary elevations and we're only seeing, we're not seeing it on one primary elevation, but we are seeing it a lot from another one, that doesn't warrant, we can't turn a blind eye and say, hey, at least from this one street, it's good. It's, we're not seeing much of it. You really have to look at these three-dimensionally. You have to look at these in the round. And that's why site conditions are so important. Is this building a mid-block property sandwiched between a bunch of taller buildings in a dense urban environment? Or is it a large building standing in a sea of asphalt by itself with visibility from all directions for a long, long distance? So that's what those sightline studies are really key to sharing with us, is we basically ask, where can you see it from? And if topography is a critical component in that, then the design has to take that into account.
Thank you, David. Another question. Window considerations were very detailed in your presentation. Are other building components considered at the same level of detail?
I mean, yes. I mean, we look at everything carefully. I think windows are a feature that are just very technical by nature, especially nowadays when we're dealing with replacement modern systems of aluminum or clad wood. And when you look at those drawings, they're just very, very detailed. Same thing as if you're looking at mechanical plans, plumbing plans, electrical plans. Certain scopes of work just have more detail to them than others by nature. Windows are something that I think someone wrote in the chat earlier, the devil is really in the details. And I think in that presentation, what I was quickly trying to convey is things can go wrong very quickly just by something that seems very small on paper. And sometimes, we're kind of fussing over inches or half inches. What it does have a big impact. So, I mean, we do generally look at everything in detail as part of a proposed project. There are just certain scopes of work that are going to naturally lend themselves to requiring more time and more discussion than others.
Thanks, David.